Hello and welcome back to another Mr. Farney Earth Science video. Last video, we covered our introduction to the volcano unit where we looked at the zones of volcanism. We looked at the different components that make up a volcano, including the interior structure and a couple words that we can use to describe kind of the bowl shape, the mouth of the volcano. In today's video, it should be much shorter. We only have a few things we're going to go over here. We're focusing on the three main types of volcanoes and the type of material that comprises each of these three volcanoes. So let's hop right into it. Here's our first slide. It overviews kind of the differences between the three main types. The traditional volcano structure that you and I think of is most likely a composite volcano. These are kind of high volcanoes. They're very steep. The second one are shield volcanoes. These are very low, not so steep, gently rising, large, spanning mountain ranges, these shield volcanoes. And the third type, they're not very tall, sometimes no taller than 500 meters, a little like higher than a quarter mile, and very, very narrow. These are cinder cone volcanoes. So these three volcanoes are the three that we're going to concern ourselves with in our volcano unit. Excuse me. So the first type we're going to look at are shield volcanoes. These are broad cone volcanoes created by the extrusion of large quantities of basaltic lava. Now, that's a lot of science words right there. Extrusion just means that lava is coming to the surface. It's going to be outside of the volcano. It's made out of mafic material. It's basaltic. So it's the same type of material that we'll see in basalt rocks kind of coming up at our mid-ocean ridges and things like that. These volcanoes are very wide. They're gently sloped. So you want to think low and long when you see shield volcanoes. So shield volcano, low and long. And a great example of this is the islands of Hawaii. Remember, they were formed from a hot spot, one of those zones of volcanism that we spoke about in the last video. But shield volcanoes, a great example are the islands of Hawaii. They are long and low, gently sloping volcanoes. The second one, these are our big fellas. These are the ones that are going to do a lot of damage if they go off. They are composite volcanoes. They're steep-sided, cone-shaped, and they're created by silica-rich, intrusive magma. So whereas our shield volcanoes are formed by lava outside, extrusive lava, our composite volcanoes are made from intrusive magma, sometimes referred to as felsic because of how much silica content comprises it. These volcanoes, they're very high, they're very steep, they're associated with very thick, very highly viscous lava that's often highly explosive, very violent. We'll talk about viscosity a little later on, but just know it's thick, very viscous lava and often highly explosive. These are the ones that are famously known to have done a lot of damage, like Mount St. Helens, May 18th, 1980. I was born May 18th, 9 years later than that, so I kind of share the anniversary of the Mount St. Helens eruption. We have Mount Vesuvius and Pompeii. Other ones of note, we have Mount Shasta, Mount Hood, and then Mount Pinatubo. Mount Pinatubo was one of the more recent massive eruptions from a volcano in modern history. So all these very famous composite volcanoes. Now we've been using these words, mafic and felsic. So to provide a little more background context, just to kind of, introduce geology a little bit more. Just keep in mind, what is mafic? What is felsic? Mafic lava, it forms the ocean crust. It's very dark colored. It's generally a more runny, a very much more lower viscosity. It moves around much quicker. So our mafic, if you see the word mafic, you want to think kind of dark colored for now. Felsic lava forms our continental crust, like our granites. It's more lightly colored. It's a little thicker. So this is just some background info for you right now. So if you see those words, mafic and felsic, you can have a little better understanding. And here are some examples of the two different types of rocks you'll see. Mafic rocks, we've already spoken about basalt. It's the darker colored. It's kind of more dense, makes up our ocean crust. Our felsic rocks, like our granite, it's a little less dense. So we can see just by looking at these pictures, without going into too much detail between the two, our mafic rocks, they're generally going to be darker colored compared to our felsic rocks, which are a little more lighter colored. So we'll get more into this later in the year when we get a little more into geology, mineralogy, petrology, all that fun stuff. Are there examples to these two rocks? Yes. And the only one I'm going to mention is my favorite boy, because we're talking volcanoes. It's our friend obsidian here. Even though it's dark colored, it's not considered a mafic rock because it is formed through felsic lava flows. Oh my gosh, Mr. Farney, that seems very confusing. Do I need to know that right now? No, that's just a little fun aside, that the chemical composition of obsidian is closer to that of felsic material than mafic material. So one thing just to kind of keep in mind, don't let the color necessarily confuse you, okay? These are all just kind of extra pieces of info that you can have to store in your bank for later. What do you have to know? Mafic rocks, basalt, felsic rocks, granite. Mafic a dark color, felsic a lighter color. Just so we have kind of a little more background info on that if you wanted it. The last type of volcano, cinder cone. These are small, steep-sided volcanoes. They kind of remind me of an anthill almost, if you take a look at them, especially like this bottom left one here. That reminds me a lot of an anthill. When these erupt, pieces of material are thrown kind of almost like straight up into the air, and then they build up that way into almost like a cone. So cinder, like fiery material in a fire, is like sometimes referred to as cinders, if you will, and cone, because of the cone shape, projected straight up into the air through small eruptions. And these are very small, very steep. Leeson Volcanic Park in the United States, that's an example of where you can find some cinder cone volcanoes. So what's a good way of keeping all three of these volcanoes kind of straight in your head when you're trying to study them? You got to go to a chart. Easiest way of remembering it. So if we're looking at shield volcanoes, and we're going to start with shield, remember those were our low, gently sloping ones. What type of material is it made out of? It's made out of our basaltic lava. That's the darker colored ones, like our basalt. There are boring eruptions. Remember, these are ocean ridges or sometimes are hot spots like Hawaii. They're non-explosive, very quiet, just kind of bubbling to the surface. And this is how we get kind of long, low, gentle slopes. Since it's not very explosive, throwing the rock everywhere, it bubbles up and slowly works its way down the mountainside. Cinder cones, these were our anthills. Remember, very short, but very narrow. We had our cinders that make up our cinder cones. Again, it's made out of a basaltic lava type, or dark colored lava type. These can be moderately explosive because they're a bit more narrow, so the pressure is more kind of localized to one area. Perhaps the conduit's more narrow compared to that of a shield volcano. And they are the smallest volcano type. Steep slopes, cone-shaped, very small, generally less than 500 meters in height. Our big boys are composite volcanoes. Hard chunks, silica-rich lava. This was our granite. This was our intrusive felsic rock material that's generally formed in layers. We get the big cascading mountain ranges associated with these types of volcanoes, like our Mount St. Helens in the northwestern United States, with our Mount Vesuvius in Italy. These are our composite volcanoes. Now they're tricky because their eruption type can range from being generally quiet to extraordinarily explosive. So it depends the type of eruption that's going to happen. Scientists can't always gauge which way is it going to go. Is it going to be relatively quiet? Is it going to be very explosive? So that's kind of what makes composite volcanoes very dangerous, is that unsureness of the type of volcanic eruption that's going to be associated with it. Again, the shape, very large, very tall, very majestic mountain ranges. So these are three types of volcanoes that we're going to concern ourselves with our class here: the types of material, associated eruptions, and the general shape. So you're going to want to be able to differentiate between these three and be able to kind of pick out some key identifiers if you were asked on that in a future assessment. So I believe that's where I want to end for the video. Yep. Next time we'll talk about eruptions, the different types of eruptions that make up our three types of volcanoes here. So I thank you for watching this video. If you have any questions, please go ahead and let me know. If not, have a great rest of your day, and I'll check back with you next time. Bye-bye.